Edward C. Tolman. Tolman's major work was entitled Purposive Behavior in Animals and Man and was published in 1932. The approach to studying behavior taken in that book has been called an objective teleology. The word objective is used to differentiate Tolman's position from other teleological positions. Teleology in general means purpose, but when Tolman talked about teleology with respect to behavior of animals and man, he was referring to observable behavior which looked as if it was goal-directed or purposive. So when Tolman referred to purposes or purposive behavior, he was talking about observable behavior that looked as if it was goal-directed. He felt that such behavior could not be ignored by psychology. He opposed the SR behavioristic positions of his day because of their molecular approach. The tendency of the SR theorist was to divide behavior up into small stimulus-response components. Tolman felt that, in doing that, they were neglecting the very essence of behavior, that is, the use of behavior as a tool to sustain life, to bring the organism into proximity of the goals that will allow the organism to continue living. Thus, Tolman's position has been referred to as an objective teleology, but he doesn't refer to purpose as some conscious striving or aspiration on the part of the organism. He refers only to overt point-atable behavior that looks as if it is goal-directed. Tolman was definitely a behaviorist, but as we shall see, he didn't mind referring to cognitive events in order to explain behavior. Tolman was a behaviorist, but he was influenced by Gestalt psychology, and Gestalt psychology insisted that totalities be studied, not individual segments. If isolated reflexes are studied, for example, the meaning of behavior is lost. What does the animal learn, according to Tolman? What the animal learns is a cognitive map. He learns what leads to what in the environment. He also learns what responses will lead to what end, or he learns what Tolman called means-end relationships. The organism doesn't learn stimulus-response connections. He learns what stimuli are there in the environment and what leads to what. What occasion leads to what other occasion. What sign leads to what other sign. In other words, Tolman's position, rather than being an example of an SR or stimulus-response position, such as Thorndike's, Pavlov's, Skinner's, and Guthrie's, Tolman's position was an SS or sign-sign system. During the development of a cognitive map, expectations are developed, which are hunches concerning what will lead to what. In the initial stages of learning, these early tentative expectations are called hypotheses, and like any hypotheses, they are either confirmed or they are not confirmed by experience. Through this process of developing expectations or hypotheses concerning what will lead to what in a given situation, a cognitive map develops. An expectancy, which is consistently confirmed, develops into what Tolman referred to as a means-end readiness, or what you might call a belief. When an expectation is consistently confirmed, then, according to Tolman, you end up believing that if you act in a certain way, a certain result will follow, or if you see a certain sign or stimulus, that another stimulus or sign will follow. Tolman's notion of reinforcement is nothing more than the confirmation of an expectancy. Learning, according to Tolman, is taking place constantly and does not depend on motivation, such as that furnished by being deprived of food or water. When a need arises, or when the organism is motivated, the organism makes use of the available cognitive maps to alleviate the need. According to Tolman, We may know many things about our environment, but only act upon that information when we need to do so. This knowledge or cognitive map has come about through reality testing or hypothesis testing and lies dormant until a need arises. In the state of need, the organism utilizes the information to bring it into proximity to those things in the environment that will alleviate his need. For example, there may be 2 drinking fountains in the building you are in right now, and you may have passed one or both of them for months or even years, and you may never have paused to take a drink, but if you became thirsty, you would immediately walk over and take a drink. Thus, for Tolman, motivation influences performance, but does not influence learning. Performance can be defined as the translation of learning into behavior. The difference between learning and performance was shown clearly in an experiment performed by Tolman and Hansig. In their experiment, they had 3 groups of rats which were trained on a complicated maze. One group of rats was never reinforced for anything they did. Members of this group were placed in the start box of the maze and allowed to ramble through it, compartment by compartment, ending up sometimes in the goal box and sometimes not. A second group was constantly reinforced. In other words, whenever they left the goal box and traversed the complicated maze and entered the goal box, they were reinforced with food. The third group of rats, and this was the most important group, was never reinforced with food in the goal box until the 11th day of the experiment. From the 11th day of the experiment on, this particular group of animals was given continuous reinforcement. In other words, the animals in group 3 did not receive reward until the 11th day, but after the 11th day, members of this group were rewarded whenever they entered the goal box. According to Tolman, learning goes on all the time. So the group that received no reinforcement, group 1, was learning about the maze as they went through it. They were learning what led to what, where things were, how they were arranged, and so forth. Group 3, the group that was not rewarded until the 11th day, were also learning what leads to what. In other words, they were developing a cognitive map of the maze. The question is, how could Tolman test his notion that learning goes on with or without reward? He tested it by observing the performance of the third group after the 11th day of the experiment. According to his theory, this group should very rapidly start performing as well as the continuously reinforced group, and in fact, that is what happened. The group that was not rewarded until the 11th day of the experiment very rapidly not only began to perform as well as the group that was reinforced all along, but they surpassed their performance. The important point is that when reward was introduced, when there was a reason for them to act upon the information they had been gathering all through the experiment, they did so immediately. This experiment was thought to provide substantial support for Tolman's theory of learning. The experiment has been replicated a number of times, and the outcome has usually been the same. This, of course, is difficult for the traditional SR theorist to handle, since the SR theorist tends to believe that reward is vital to the learning process and that the learning of a complex skill occurs in small steps over a long period of time. The points that we have made so far can be summarized as follows. 1. The organism brings to a problem-solving situation systematic modes of attack. These systematic modes of attack are based largely on prior experience. 2. The cognitive field is tentatively organized according to the hypotheses of the learner. The hypotheses which survive are those that correspond best with reality. These hypotheses or expectations are confirmed by success in goal achievement. 3. After a while, a clearly established cognitive structure is available for use under altered conditions, as when frequently used paths to the goal are blocked. Having a cognitive map available, when a frequently used path is blocked, the animal simply chooses an alternative path. 4. When there is some sort of demand or motive to be satisfied, the organism will make use of its available information, and this, for Tolman, is the basis for the very important distinction between learning and performance. We saw a moment ago that in a latent learning experiment, rats who were first not rewarded and then rewarded utilized immediately the information they had learned during the time that they were not being rewarded. Latent learning can be defined as learning that occurs in the absence of reward. In addition to the latent learning experiments, support for Tolman's theory came from a rash of experiments on place learning versus response learning. One such experiment utilized a cross maze. This is a maze that is shaped like a cross, and its 4 ends can be used either as start boxes or as goal boxes. Using the cross maze, one group of rats learned to enter the maze from one of the 4 entrances and to turn right to get food. Then they were taken to the entrance directly opposite from the entrance that they had started the experiment in, and again they learned to make a right turn to get food. In other words, what this particular group of animals was learning was to make a right-hand turn from wherever they started in order to get food. This group was therefore called the response learning group. Another group of animals was started at one of the entrances of the cross maze and learned to turn right in order to get food. After preliminary training, they were taken on alternate trials to the opposite entrance from which they had to run left in order to get food. In other words, this group of rats was always rewarded in the same place. Starting in one position, they turned right in order to reach the goal box, and starting in the other position, they had to turn left in order to reach the goal box. This group was called the place learning group. It was found that the latter group learned the problem much faster than the former group. Tolman and his followers concluded, on the basis of this and other research, that place learning is easier than response learning, and again this fits into his cognitive map idea that we learn places and things about places and not specific responses to situations. Another experimental arrangement that is thought to support Tolman's position is referred to as probability matching. The typical probability matching experiment usually involves 3 lights. One light is placed above the other 2 lights so that there is a light on the left of the subject, a light on the right of the subject, and a light in the middle of those 2 and slightly above them. The light in the middle is a signal light. The subject is instructed to guess whether the left light or the right light is going to come on after the signal light goes on. The sequence of events in this type of experiment is as follows. First, the signal light goes on, and when it does, the subject says left or right, depending on which light he thinks will go on. Under these circumstances, the experimenter can manipulate the situation any way he wants to. He can have the left light come on 100% of the time and the right light come on 0% of the time. Or he can have the right light come on 75% of the time and the left light 25% of the time, and so forth. What happens is that the subject's guesses about which light will come on comes to match how the lights are programmed to come on. If, for example, the left light is programmed to come on 80% of the time and the right light 20% of the time, the subject will eventually guess that the left light will come on 80% of the time and the right light 20% of the time. And this is called probability matching. Not only is there the phenomenon of probability matching, but there is also the phenomenon of probability tracking. As we just mentioned, if the initial stage of the experiment is set up so that 2 lights come on 80% of the time and 20% of the time, the subject will come to predict the light coming on approximately in those proportions. After the subject is guessing accurately the proportions with which the 2 lights are coming on, proportions can be changed to 70-30, 35-65, or anything else, and within a short period of time, the subject will match the new probabilities. The probabilities can be changed throughout the course of the experiment, and the subject will track the probabilities, whatever they are, with amazing accuracy. These findings are very difficult for most SR theories to handle, but relatively easy for Tolman's theory to account for. For Tolman, probability matching is a matter of formulating hypotheses as to which light is going to come on. Some of these hypotheses would be confirmed, and others would not be. Eventually, the subject's behavior would correspond to the hypotheses that had been confirmed, and probability matching would result. Tolman was the first theorist to use the terms independent variable, intervening variable, and dependent variable in psychology. He borrowed the terms from physics, and he felt that a good psychological theory should specify the variables that were going to be systematically manipulated by the experimenter, and those would be the independent variables, the theoretical concepts, which were the intervening variables, and the variables that were going to be measured, which of course would be the dependent variables. Tolman was therefore a very scientifically oriented theorist who stuck extremely close to the data and saw the necessity of operationally defining every major concept in his theory. As a matter of fact, Clark Hull, who many think of as the most rigorous and scientific of the learning theorists, borrowed most of his format for his theory from Tolman. So Tolman was the first in psychology to develop a theory based on a combination of highly specified input variables, which would be the independent variables, and intervening variables, which were his theoretical variables, and output variables, which were the dependent variables. An example of one of Tolman's independent variables was maintenance schedule, which he symbolized M. This had to do with how often an animal was fed or given water. An intervening variable that was coordinated with M had to do with demands, motivations, and/or persistence. So the independent variable M, or maintenance schedule, was related to the theoretical internal condition of demand or motivational persistence. Another of his independent variables was appropriateness of the goal object, symbolized G, which was related to the intervening variable of appetite, taste, or preference. Another independent variable was types and modes of stimuli provided in the experiment, which was symbolized S, and this was related to the intervening variable of sensory differentiation. Another independent variable was types of motor responses required for the task, and this was symbolized R, and was related to the intervening variable of motor skills and capacities. Finally, the independent variable, which is symbolized the summation of OBO, or the cumulative nature and number of trials, was related to the intervening variable which corresponded to the development of a cognitive map. In other words, as training trials continued, the cognitive map was thought to become more fully developed. The effects of Tolman's independent variables had to be measurable. The intervening variables are not directly measurable and are postulated in order to explain the relationship between the independent variables on the one hand and the dependent variables on the other hand. Both the independent variables are observable and the dependent variables are observable. The dependent variables are always performance measures. That is, they must be measures of overt behavior on the part of the organism. Although Tolman was interested in purposive behavior on the part of the behaving organism, he had the following to say about animal research. Quote, "Everything important in psychology, except perhaps such matters as the building up of the superego, that is, everything save matters as involve society and words, can be investigated in essence through the continued experimental and theoretical analysis of the determiners of rat behavior in the choice point in a maze." End quote. It's tempting to misunderstand Tolman because he uses theoretical cognitive concepts like cognitive map. Elsewhere, he uses the term vicarious trial and error to describe the hesitation of the rat at the choice point, where it looks as if the rat is weighing the alternatives and saying, should I go this way or should I go that way? In other words, VTE, or vicarious trial and error, looks as if the rat is reasoning out the problem before he makes his choice. But again, Tolman is describing behavior. His theory, in spite of its use of cognitive terminology, is very objective and scientific, and Tolman was very much a behaviorist, although not the same kind of behaviorist as people like Skinner, Guthrie, Hull, or Pavlov. Tolman's interest was in explaining purposive or goal-directed behavior rather than isolated stimulus-response associations. Tolman's theory of learning is still very popular today and promises to remain popular for some time to come. And with that, we will end our discussion of Tolman's theory of learning.